Question 3 is a perfect example of what we had said earlier. So this is the nucleus of an atom in the center. So if you count this, so the particle inside the nucleus is what you call nucleons. The nucleons in the nucleus. The whole position, the place is called nucleus. The particles are called nucleons. Nucleons consist of protons and neutrons. If we look back at this 15(7) nitrogen, which is given in the question, this is the nuclide notation, the international standard. The number at the bottom is called proton or atomic number. It tells you the number of protons in the nucleus. So there are 7 protons. If you count the black stuff there's 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 of that black stuff. It cannot be protons. The black stuff is not protons because you have 8 of the black stuff. You count again, 1, 2, 3, 4, 5, 6, 7, 8. You cannot have 8 protons since you only have 7 protons for nitrogen. But the white color stuff, 1, 2, 3, 4, 5, 6, 7, you have 7 of that non-bolded stuff. So that must be your protons. So B must be protons because it's not the darkened stuff. Then what is this other darkened stuff then? Nucleons. Nucleons are defined as protons and the neutrons in the nucleus of an atom. As you know, how do you know there are 8 neutrons? Because this on top is what you call nucleon, or we can call it mass number. So nucleon number minus the proton number will tell you the number of neutrons. As you know, nucleon number is equal to proton number, basically the number of protons plus the neutron number. So usually to get these, we do the number on the top, nucleon number, minus the proton number. So if I want this, I can move this to the other side, so I can get neutron number, basically how many neutrons there are. I do a little bit of simple math, so that one minus the proton number. So the number on top minus the number at the bottom will give us 8 neutrons. In fact, that was what we have done. We have named the particles. Now they say this atom was nitrogen 7 and 15. This is an atom because the atom has no charge, so you have 7 protons and 7 electrons. There are 2 bits to this question, that's why there are 3 lines and there are 2 marks. If you read the question, they say it forms an ion with N3 minus. First of all, describe how it is formed. So the atom become N3 minus. N3 minus, this represent anion because it's negatively charged, and you have a 3 minus because you have gained 3 electrons. If you think about the outer shell electrons, 1, 2, 3, 4, 5. There are 5 outer shell electrons because nitrogen is in period 2, but it's in group 5 as given in the periodic table. Group number tells you how many outer shell electrons do you have. Group 5, 1, 2, 3, 4, 5. Nitrogen is basically 2, 5. Now you gain 3 electrons and it will become 2, 8 to have a fully filled outer shell, and that's the reason why this ion is stable, because you want to gain 3 electrons to become a fully filled outer shell. So first of all, describe how you form it. So the nitrogen atom, basically this one with a 2,5 electronic configuration, 2,5, gains 3 electrons to form N3 minus anion, or just N3 minus ions. On to the second bit, why this ion is stable. Stable ion because you have a fully filled, because it has fully filled valence shell. If you have never used this word valence, V-A-L-E-N-C-E, you can use the word outermost. They mean the exact same thing. Outermost refer to the one which is most outside. Valence refer to the one which is most outside. Now complete this table. This is straight from the syllabus. This is a year 9 syllabus, and you are also required in your syllabus. Candidates should be able to complete this table. Electrons are negatively charged, as you could see that. Protons are positively charged. Neutrons have no charge. In terms of masses, mass is not charged. Charge has plus and minus. Mass has no plus or no minus. It's always positive. Neutron has the same mass as proton, so they have the same 1 and 1. Electron is the lightest. Electron is roughly 2000 times lighter. So there is an exact answer for this, but it's enough to write 1 over 2000 to save your memory of having to remember the exact number, which is around 1 over 1846 or 1 over 1856. I can't remember the exact number. I always remember it's about 2000 times lighter, 2000 times less heavy. Less heavy means 1 over 2000 because it's lesser than 1. That's it for that 2 marks. In the next question, number 4, so this is a question about isotopes. They say these atoms, not 3 atoms, isotopes of the same element. How the data in the table, very, very important, data in the table. For that 2 marks, you are asked to define isotopes, which is part of your syllabus. Candidates should be able to define isotopes in terms of same number of protons. They say use the data in the table, so they give me protons, neutrons, and electrons, so I have to say same number of electrons as well, because use data in the table. So these atoms, what is it they have they are the same? What is it they have they are different? They have same number of protons and electrons, but what is different? Okay, so now I need to focus on what is different. As you can see, these are 8, 9, and 10 neutrons. Protons and neutrons are the nucleons. They are the particles in the nucleus of an atom, whereas the electrons are in the shells outside the nucleus, or you can say surrounding the nucleus. So what happened is, but these and these have the same number. These neutrons are different, so but different number of neutrons. So do not confuse how many you have with where you can find them. Be very, very careful. You don't want to lose the 2 marks at all. So let's get started on this thing. So this is completing the sentences. So fill in the blank. You will see that this is a 4-mark question. So this is around 1, 2, 3, 4, 5 there. So one of these must be worth 1 mark, around 1 mark each. So we know periodic table, list the elements. How are the elements listed? In order of, that is in order of proton, or you can say atomic number. Choose whichever one, but these things are given in a periodic table. You will see element number 1 is, well, hydrogen, element number 2 is helium, number 3 is lithium, and so on and so forth, because they have different atomic number, go from 1, 2, 3, 4, etc., etc. Now, what is found on the left-hand side and what is found on the right-hand side, this should be something you know in terms of metallic as well as non-metallic, because the metals are what you would describe as a group 1, 2, and 3, and the non-metals are basically your group 4, 5, 6, 7, and 8. But group 8 is fully filled outer shell, so fully filled outermost, or I used in the last tutorial, I used the term valence shell. So therefore, they don't react very much. So noble gases, we don't associate with forming any bonding at all. Typically, therefore, we don't consider them as non-metals, even though they are non-metals, because these are the ones that form bonds. This doesn't form bond because of this particular reason. Vertical columns, so going up and down. So vertical is going up and down, and horizontal is going across. Alright, so up and down refers to, well, up and down vertical. That are what you call groups. And the horizontal rows are what you call periods. So first row of the periodic table we'll call period 1. Second row from lithium to neon will be called period 2. From sodium to argon, there's your third row, it's called period 3. Group 1 would be like lithium, sodium, potassium, etc., etc. That is called group 1. Group 2 will be like beryllium, magnesium, and then calcium, etc., etc. For that 4 marks, you really should be scoring that if you know your periodic table. In the next question, so these are just arrangement of electrons, basically how the electrons are arranged. They can use the term configuration or some other terms. Looking at these, you can tell this is first shell and this is second shell. As you know, if you only fill up to second shell, so this is called period 2 element, because you go across, you only fill up to second shell. And your outermost electrons is only 1, because the first shell is fully filled, and the outermost shell, meaning the valence shell, is only 1 electrons. Therefore, you can call it group 1, period 2, because there are 2 shells being filled. As for this one, this must be group 5, but period 2. This one must be group 8 and also period 2. So if I just write period number on top here, this is 2 shells being occupied, so it's period 2, second row. Second row of the periodic table, because it fills 2 shells, so fill up to 2 circles or 2 shells, period 2. This one fills up to first, second, and third shell, so this must be period 3. And then we have 1 electrons in the outer shell, so there's group 1, this is group 3, this is group 7, and this is first, second, and third shell, first, second, and third shell, so it's period 3 and period 3. Now we got to use the letters because that's what the instructions say. You can use it once, more than once, or not at all. Which one has a proton number 17? Element consists of atoms, and when you have atoms, we know that number of protons equal to number of electrons. These are electronic configurations, so the sum of the electrons, there are 2 plus 1, there are 3 electrons, 2 plus 5 is 7 electrons, 2 plus 8 is 10 electrons, 2 plus 8 plus 1 is 11 electrons, etc., etc. We're looking for the sum where the sum of electrons equal to 17. That will be equal to the proton number, because for element which contain only one type of atoms, the number of protons equal to number of electrons. That's why the answer there must be Z, because 2 plus 8 plus 7, the number of electrons, sum them up. In the first shell, the second shell, and the third shell, you get 17 electrons. Number of protons equal to number of electrons. Proton number 17, 17 electrons, because it's atom. In the next one, which element combines with 3 hydrogen atoms? 3 hydrogen atoms, covalent. So this is non-metal, and the fact that we want covalent compounds, we are looking for non-metal. If we look at group 1, this is group 1, so we can say group 1, 2, and 3 are what you call metals. If we are looking at group 4, 5, 6, 7, so they are your non-metals. So we're looking with to combine with hydrogen. So this is a non-metal. We want covalent, so we want to share electrons, and you share electrons between non-metal and non-metal. So what we have is cannot be the answer because it's group 1, cannot be the answer because it's group 1, cannot be the answer because it's group 3, cannot be the answer because it's fully filled already. So it must be V or it must be Z, but then it combined with 3 hydrogen atoms. This one only need to share 1 electrons. Hydrogen will share 1 electrons. If you can imagine hydrogen, the electronic configuration is in the first shell. First period, it only has 1 electron. It will share 1 electron. This one share 1 electron. If you have hydrogen and Z, you will just get 1 H and 1 Z. But this thing, 3 hydrogen atoms. So we are looking at this 5 there, because 5 plus 3, so 5 need to share 3 electrons, 1 from each hydrogen. So I share 3 hydrogen, therefore I share 3 electrons. That will give me 8 electrons in the outer shell. So that's why V must be the answer there, because you want to form VH3. One of the V share 3 electrons, 1 from each of the hydrogen there. Now, which 2 elements are in the same group? Same group means same number of valence electrons. The outermost electron is the same. This is group 1, this is group 1. So we're looking at U and also X. Which element does not form an oxide? So, does not bond at all. Does not form any bond. Whether it's ionic, whether it's covalent, does not form any kind of bond. We're looking at fully filled outer shell, which are the noble gases. This is 2 plus 8 is 10. So proton number 10, that is neon. But we want the letter, which is W. Last but not least, deduce the formula. You want the formula formed between Y and Z. So Y is 2 at 3, Z is 2 at 7. So Y is 2 at 3, Z is 2 at 7. This is a group 3, so we can consider it as metal. This is a group 7. This is a non-metal. So essentially we can be thinking about ionic bonding. So if I give 1 electron there, so give 1 electrons, but I need to give away 3 electrons. So I need another 2 at 7, I give another electron there, and I have another 2 at 7, I give another electron there. So altogether I give 3 electrons away, 1 to each Z, 1 to each Z, and 1 to each Z. So altogether I will have Y3 plus, because I lost 3 electrons. When I lose 3 electrons, I get Y3 plus, and then I'll get Z minus, but I need 3 of it. So altogether, my formula is going to be YZ3, where it's ionic, 1 of it, and 3 of the Z minus. Moving on to the next question. So this is fill in the blank again. This is about periodic table. This is about the elements in group 1. So the group 1 metals are what you call the alkali metals as part of your metal case study. They are all in group 1 because in the outermost shell or in the valence shell, they have 1 electron. They have 1 electron in the outermost shell. For example, lithium will be 2,1, sodium will be 2,8,1, potassium will be 2,8,8,1. As you could see in the outermost shell, all of them have 1 electrons there. These elements, basically the group 1 elements, react with water to produce metal something. They will give you metal hydroxide and also hydrogen gas. If you think about it, these are your case study, your word equation. So group 1 metal, basically reactive metal, plus your water. So water is liquid, and then they'll give you group 1 metal hydroxide. These are your word equation, which you really must master. Hydrogen gas is basically H2 gas, and this reaction, vigorous means more reactive, more extreme, more reactive, as the group is descended. Descended means go down the group. Go down the group 1. As you go down the group 1, these electrons are easier to be lost because the electrons are further away from the nucleus. Only 1 shell, 2 shells inside, 3 shells inside. Your nucleus, which contain your protons, become less attracted to the valence electron. And since your valence electron is less attracted to the protons, it's easier to be lost. If it is easier to be lost, they become more reactive. And therefore, it becomes more reactive, more extreme, more vigorous going down the group 1 because easier to lose your outer shell electrons. Easier to lose valence, or you can say outermost electrons. Question 9, basically this is a 6-mark question on filling in the blank again. So this is about non-metals. So we find non-metals on the right-hand side of the periodic table. In terms of melting point, the non-metals example, N2, O2, H2, Cl2, Br2, I2, these are all your case studies. These are all, well, not all of them, but the common one. Up until there, they are gases at room temperature and pressure, which is around 25 degrees Celsius. As you know, Br2 is a liquid, and also I2 is a gas as part of your group 7 chemistry that you learn in non-metals. In terms of melting point, they are already gases by the time they reach 25 degrees Celsius because they have low melting point. They all are simple covalent molecules. In your syllabus under structure and bonding, you can also call this simple molecular structure, and therefore you are just breaking the weak intermolecular forces. That's why they have low melting and boiling point. In terms of density, they are very, very light as gases, so they have low density, where density is mass over volume. They occupy a big volume, they have low mass, therefore they have low density. Forming negative ions has another name called anions. So to form negative ions, the nonmetals will gain electrons, they accept electrons, they receive electrons to form anion. And now we talk about the stability of the negative ions. Why? Why does certain nonmetal only gain 2 electrons, only gain 3 electrons, some of them gain 1 electrons? Because to complete the outer shell, so you want the outer electron shell, or you want the valence shell in order to be filled. You can use the word FILLED, or you can use the word full, but just choose either one to complete the sentence. Now the next one, nonmetals combined with metals. Nonmetal with metal, you will get ionic compound. If it is nonmetal with nonmetal, then you will get covalent compound, where you share electrons for covalent and you transfer electrons from the metal to the nonmetal to form ionic compound. In this next question, so question 11, so properties of some elements. We gotta use the letters to answer the questions. Which one is a liquid? Room temperature is 25 degrees Celsius. You think about melting point, which is solid to liquid, and boiling point, which is liquid to gas. So you're looking for 25 degrees Celsius somewhere in between. 25 degrees Celsius is below this. A is already at 25 degrees Celsius. It hasn't melted yet because the melting point is way higher than 25. So A is still a solid at 25 degrees Celsius. This thing is way too high. It is still a solid. B is still a solid at 25 degrees Celsius. 63 is higher than 25, so it hasn't melted yet, so it is still a solid. And minus 7 and minus 248 is lower than this. It has melted, but this one is minus 246, so 25 degrees Celsius, it already boiled at 25 degrees Celsius, so that is a gas, whereas 25 degrees Celsius sits in between the melting and boiling point. That is why that is a liquid, because 25 degrees Celsius is between the melting and the boiling point. So we've gotten our answer there as D. Which elements are metals, and give a reason? So this is looking at the valence electrons, the outermost shell, the one which are filled the last. So from there I can see this is group 6, this is group 3, this is group 1, this is group 7, this is group 8. From the valence electrons, the number of valence electrons. So which elements are metals? That must be C. And we're also looking at group 3, that must be B, because they say R and they also have plural. So think about it. This one is very obvious. This one is group 3. Some students might miss this one. This is actually aluminium. 2 plus 8 plus 3 is 13. The 13th element in the periodic table is aluminium. Aluminium is a well-known metal. Okay, so what can I say? B has 3 outermost, or I can use the word valence, whichever one you like, but it's to do with the electrons. So therefore, group 3 element. Alright, so what is the next one? C. C has 1 outermost shell electrons. C has 1 outermost or valence electron. Therefore, it's a group 1 element. So group 1 and group 3 elements are metals. Now, which element is in group 1? So very obvious based on what we said already. So there was C, and this is a singular question. Which element is? So this is about breaking down the question. The next one, very obvious also, is an inert gas. Inert means unreactive, and as you know, even the nonmetals can form covalent bond with themselves, except for group 8, because fully filled outer shell, fully filled valence shell. In fact, I am wasting my time. I should really put this down there. Fully filled valence shell. Fully filled valence. If you don't like that word, you can say outermost. Just stick with one, whichever one you like. The outermost shell is completely full already, so that's why it doesn't gain, it doesn't lose, it doesn't share. This is the one which is completely full, is element E. And that's it really for this tutorial. So I've done another 4 pages, and I hope that has been useful. Don't forget to click the button on the bottom right to subscribe to the channel. There's ptet.chemistry on YouTube, and follow me at ptet.chemistry on Instagram, Facebook, and Twitter to get connected. Thank you for watching, and I'll see you in the next tutorial video.